Our first example today comes from this article about the influence of winter supplement feeding on wild turkeys. So this data was collected over 2 different winters, and there were different weather in the 2 winters. In 2001, there was frequent snowstorms, which provided limited ground forage, and however, the snow was minimal to absent in 2002. So they also did some different supplemental feeding regimes because of that weather. And this is a question that was on the fall 2018 test, so that's why it says page 4. This is not in your book. So we had a random sample of 7 juvenile turkeys in 2002, and they had a mean of 462 grams of body fat with a standard deviation of 35 grams. And we want to find a 95% confidence interval for the true mean. So let's first of all write down the givens. Okay, so we have n equals 7. We have x bar, sample mean of 462, and a standard deviation of 35, and we desire a confidence level of 95%. So our formula for a 95% confidence interval for mu, the true mean, equals x bar plus and minus t star times s over the square root of n. So we know x bar, s, and n. What we need is t star, and then we'll have everything we need. To find t star, we need the degrees of freedom, which is n minus 1, which equals 7 minus 1, which equals 6. So we find the degrees of freedom down the side, and we go to 6, and then we go across to 95%. And that tells us that T star is 2.447. And so now we can put everything in our formula, which gives us 462 plus or minus 2.447 times 35 over the square root of 7, which gives us 462 plus or minus 32.37, which is our margin of error, for a final confidence interval of 429.62 to 494.37. Now the next question, the next question is actually giving us an interval for the 2001 season of 445 to 499. And it's asking for the sample mean and the margin of error. So we know the sample mean is at the center, and we can find the center by adding the 2 endpoints and dividing by 2, which gives us 472. And the margin of error is the number we added to 472 to get to 499, and we subtracted it from 472 to get to 445. So there's multiple ways we can find this. For example, we could do 472 minus 445 equals 27, or we could do 499 minus 472 equals 27. To answer the next question, which says, based on this data, does it appear that the juvenile turkeys had different mean body fat in 2001 than 2002? So to answer that question, we want to look at, do the intervals overlap? Okay, and yes, intervals overlap. So we do not have evidence of a true difference. Let's also look at this next question here, which is about a 95% confidence interval for the true mean amount of planned holiday gift spending for 2018 based on a random sample of over 7,000 adults is $630 to $646. Which of the following statements are true? So number 7, 95% of all possible samples of 7,313 adults will produce a confidence interval which contains the true mean holiday gift spending. So this is saying 95% of all possible samples have a good confidence, will have a good confidence interval, and that is true. That's what the central limit theorem tells us. And skipping down to number 11, which says we can be 95% confident that the true mean is in that interval. Yes. So this is the correct interpretation of a confidence interval. So by definition, this is true. Okay. And the other three statements are all false. Okay, we're not saying that 95% of the shoppers plan to spend in that interval. We're saying that's where we think the mean is, not 95% of the population. Number 9 is false because it's talking about really the exact same thing that number 8 says. And number 10, again, we can't talk about probability in association with a true mean value because it's one single value. There's no probability involved. So all of these other ones are false. Okay, and we'll finish up here with some sample size calculations. Sample sizes are harder for means than they are for percentages because we have no safe guess to use when we don't know sigma. Okay, so our two choices are we can use estimates from previous research or we can make an educated guess. And we'll come back to this in a second. Now when doing confidence intervals for means, we have to use T star. But here for sample sizes, we're going to have to go back to using Z star because we can't use T star because we don't know the sample size. That's what we're trying to get. So from the last example, we had a standard deviation of 35. That was a sample standard deviation, but we're going to use it in this problem as a population standard deviation because it's our best guess. The margin of error in that example was 32.37, and suppose we wanted a margin of error instead of 25. So suppose we desire a margin of error of 10 grams with 95% confidence. So our givens are S equals 35, or I should have said sigma equals 35. Margin of error equals 10. And now notice the units. The units are not percentages. So do not move the decimal point. You do, you'll get some astronomically large sample size. So back to our givens, our confidence level of 95% tells us to use our old favorite Z star, the ever popular 1.96, gives us N equals 1.96 times 35 divided by 10. square the whole quantity, gives us 47.06. Okay, but we have to round that up. If we want even a small part of the turkey to get our margin of error of 10 grams, we need to take the whole turkey. So round up just like with sample sizes for percentages. So back to this second method. Okay, make an educated guess. And to make an educated guess, which is really simple method, okay, and what you can do is estimate the smallest possible value for the quantity you're measuring and estimate the largest possible value. Then your guess will be the difference between the largest and the smallest divided by 4. So let's do an example, and let's say we want to find a sample size to estimate the mean weight of domestic house cats with a margin of error of 1.5 pounds with 95% confidence. So my guess for the smallest a cat could possibly be, an adult cat, is 4 pounds. And the largest is 32 pounds. Okay, you want to aim low or high on your guesses, not try to be too exact. So my best guess for a standard deviation is sigma equals 32 minus 4, largest guess minus smallest guess, divided by 4. That's just part of the equation, not something you look up. So that gives us 7, and now we can plug everything in the equation, just like we did before. So n equals 1.96 times 7 divided by 1.5. Square the whole quantity, which would mean we would need 84 adult cats in our sample to get a margin of error of 1.5 pounds. So at this point, you can finish up in class exercise 17, or start and finish it if you haven't done that yet, and then go on and do in class exercise 18, which is some sample size problems. And remember that I am going to find a time to grade these, so we'll do that like via Zoom. So don't let yourself get too far behind on those. Also, don't forget there's a new WebAssign already posted on confidence intervals for the mean, and this includes a couple questions about sample sizes. And that is due in 1 week, next Tuesday, April 14.